So in part 3, we're going to take a look at the rational inequalities. And so this is example 2, part D, and it shows us the factor of x minus 2 over the factor of x plus 3 is less than or equal to 0. So the process is pretty much the same. We need to find our boundary numbers. We need to recognize that we will have some impacts with those vertical asymptotes, but other than that, the process is going to be the same. So it's already compared to 0. Everything over here is already in terms of a single fraction. If it were not, you would have to combine those rational parts into a single fraction. So our boundary numbers, we're going to get a boundary number from the top, which is going to be 2. We're going to get another boundary number from the bottom, which is -3. I'm going to flag that with a VA, reminding myself that that's a vertical asymptote. So the numerator gives us a +2, the denominator gives us a -3. We're going to go build the sign chart. So same as last time, we're going to have our test value. We're going to list our factors. So there's the polynomial from the top and the polynomial from the denominator. Have our result. Our number line contains a -3 and a +2. Go. I'm going to flag that -3, even though it doesn't look like a -3. Put that up, -3 with VA for vertical asymptote. And that's going to remind me when I get to the end some points. So, okay, same thing as before. Find something, a number in that region, and then test it. So we're going to use -4. -4 minus 2 is a negative. -4 plus 3 is a negative. This time, a negative divided by a negative is a positive. So I did change the terminology on how I get my result. Between -3 and 2 is a 0. 0 minus 2 is negative. 0 plus 3 is positive. A negative divided by a positive is a negative. +2, something larger, we can use 3. 3 minus 2 is positive. 3 plus 3 is positive. And a positive divided by positive is positive. I'm expecting these signs to alternate because I don't have any multiplicities that are impacting anything. So I expect that alternating signs. Okay, according to the inequality, we need the regions that are negative. So we need to pick the negative region. Pick negative region. That's because we're less than or equal to 0. And our negative region is sitting right here. So our answer then is going to go from -3 to 2. Now I can bracket in the 2 according to the inequality. It is inclusive. We need to include that endpoint. I cannot bracket in the -3 because the -3 comes from a vertical asymptote. And if I include -3 as part of my solution set, then I'm going to end up dividing by 0, which we can't do. So that's why I flagged that vertical asymptote to remind me to use a parenthesis there no matter what the inequality statement says. And there it is. There's your first rational inequality. Let's do 2 more examples. Each one's going to get a little more complicated as usual. So part E says x minus 1 times the factor of x minus 3. That's all in the numerator. The denominator contains x plus 1. And it would be greater than or equal to 0. So our boundary numbers are going to be a +1, +3, and -4. And I'm going to flag that as my vertical asymptote. So they've done all the work for me. It's already compared to 0, and it's already a single fraction. So they've done all the work for me. They really have. Best values. Let's see, we have x minus 1, or x minus 3. Most of your time is going to be spent building these sign charts. Then we're going to have our result. 3 numbers on our number line. In numerical order, we have -4, +1, and +3. So we can use -5. When I plug -5 into each of those factors, they're all 3 going to be negative. What happens when you take a negative times negative and divide it by a negative? It doesn't really matter when you're talking about multiplication or division. You're counting the number of signs. We have 3 negative signs. That's an odd number. We know the result's going to be negative. Between -4 and 1, we can use 0. 0 minus 1 is still negative. 0 minus 3 is still negative, but 0 plus 4 is now positive. So when I divide a negative by a negative and multiply it by a positive, you're going to end up with a positive. Between 1 and 3, we can use a 2. 2 minus 1 is now positive. 2 minus 3 is still negative. 2 plus 4 is positive. The net result when you multiply or divide a positive, a negative, and a positive is a negative. Larger than 3, let's use 10 just to show you can use anything out there. 10 minus 1 is positive. 10 minus 3 is positive. And 10 plus 4 is positive. And the net result when you're multiplying or dividing 3 positives is a positive. There it is. There's our sign chart. Again, I'm expecting that alternating sign at the end because we don't have any multiplicity issues. According to the inequality, we need to pick the positive regions. I'm going to pick the positive regions because we're greater than or equal to 0. So my positive regions are here and here. So we're going to go from -4 to 1. Oops, I need to flag my vertical asymptote sitting right there at -4. So that tells me to use a parenthesis, a bracket on the 1 because we're including it on the inequality. And then we're going to go from 3 to infinity. So there it is. So again, the parenthesis on the -4 is because it comes from that vertical asymptote. Okay, one more before moving on. So this is part F on example 2. So we have x plus 2 quantity squared. And that's going to be over x squared minus 1 in the denominator. So this one's not in factor form. We need to go factor it. Well, a little bit of factor form. So the numerator's fine. It is already factored. The x plus 2 appears twice. Actually, you know what? Let's leave it as a square. And the reason I want to leave it as a square is because that's talking about multiplicity and it's easier to see it from that form. So I'm going to leave it in that form. The denominator factors into x plus 1 and x minus 1. So our boundary numbers are going to be a -2 from the numerator, a -1 from the denominator, and a +1 from the denominator. We've got our boundary numbers. We know that both of these guys are vertical asymptotes. So I'll keep track of them. So as factors, I have x plus 2. I prefer to list it as a quantity squared. It just is more concise. It's one less line on the chart. If you want, you can list x plus 2 and then another x plus 2. Entirely up to you. I have x plus 1 and I have x minus 1. So learning to build the sign charts in this class will help you when you go to take your calculus course. You'll use sign charts there to sketch curves and things like that. So it's kind of handy for a later class. -2, -1, and +1. Okay, so now we need to pick numbers in each of those regions and see what happens. You know what? Let's make it a little bit easier on us. Does it really matter what number I plug in for this factor? When I plug in any value for x and square it, it won't always be positive. It will. So it doesn't matter what number we use. This line is always going to be positive. So that's kind of nice. So really, we're just plugging into the factors from the denominator. So to the left of -2, we'll use -3. -3 plus 1 is a negative. -3 minus 1 is a negative. The net result when you multiply or dividing here would be a positive. Between -2 and -1, let's use -1.5. So -1.5 plus 1 is negative. -1.5 minus 1 is still negative. The net result is a positive. Why is the sign not changing? This -2 is coming from this factor. And because of its multiplicity, the sign is not changing. That balance coming into play. Okay, what about between -1 and 1? We'll use a 0. So 0 plus 1 is now positive. 0 minus 1 is still negative. The net result there is a negative. We'll use something larger than 1, like a 2. 2 plus 1 is positive. 2 minus 1 is positive. The net result is a positive. So we've got our sign chart built. According to the inequality, we're going to pick the negative regions because of the less than or equal to. So then our answer is going to come from now. Don't forget the -1 and the +1 are our vertical asymptotes. So even though the inequality says to include them, we cannot. So our negatives are our only negative region is sitting right here. So we're going to go between -1 and 1, but we're going to use parentheses. I can't use a bracket and bracket it in. So, and there's 3 examples of the rational inequalities.